We are going to continue talking about graphing a whole bunch of different types of equations. Here we're going to talk about our sinusoidal graphs. The two we're going to be focusing on, or the one we're going to focus on today, is the sine. So think about trigonometry, your sine, cosine, and tangent. All right, so the parent function of sine is pretty straightforward. We're going to take y, or f of x, equals the sine of x. This is the parent function. Nothing's being done to it. This is sine in its most basic form. Now, if we think about this, numbers that we're going to substitute in for x here are going to be degrees. 30 degrees, 90 degrees, 67 degrees, 42 degrees, all that loveliness. And eventually, we see that if we travel enough degrees, we'll just start back over again. So if you think about it, a circle is 360 degrees total. If we kind of draw in our x and y axes here, and if we start at this line and we go up that way, we'll see that this vertical line will be 90 degrees. The line way over here will be 180 degrees. We keep going, we'll get 270, and finally all the way around will be 360. Or this line here, if we're starting out, haven't moved yet, we've moved 0 degrees. And if you go all the way around, it's 360. If we were to go a different direction, we call that negative degrees. So this would be a negative 90 degrees or negative 180 degrees, and keep going around. And they kind of mean the same thing. If you want to check in your calculator, type sine of 270 and of negative 90. It should give you the exact same answer, which is kind of interesting. So enough about that. Let's get back to our parent function here. Now it's really important for what your calculator today, make sure it is in degrees. So hit mode, make sure degrees is highlighted. If not, you're going to get the wrong answers and nothing will be correct. So, if we were to pick a whole bunch of values for x, just kind of make a t-chart almost. We'll start at 0 degrees. We'll do 30 degrees and 45 degrees and 60 and 90. These are the nice numbers. And if we keep going until we get to 360 degrees, keep going, we're just going to graph all of these points. You can type those in your calculator. Take sine of 0. What does that equal? Take sine of 90. What does that equal? In fact, we'll write some of those down. I'm actually going to make the t-chart sideways here. So if we use 0 degrees, type that in, our answer is actually 0. If we type in 30 degrees, our answer is actually a half. If we type in 40 or 60 degrees, if we type in 45 degrees or 60 degrees, it's going to give us this weird decimal, which is okay. But I don't have enough room on here to write all of those. So go ahead and write that. It's 0.7 and then 0.87. So kind of a little bit of difference. But let's keep going. Let's go to 90 degrees. That'll actually give us a positive 1. And if we keep going around, keep picking these. If we pick 150 degrees, it'll actually give us a half again. If we pick 180 degrees, it'll give us 0. If we pick 240 degrees, that's going to give us a negative 1/2. So we start to see kind of a pattern. If we pick, and I'm going to keep going here, if we pick 270 degrees, that'll give us -1. And then if we pick 360 degrees, that brings us back to 0. And if we kept going like this, we would see a pattern. We'd go up to +1, back down to 0, down to -1, and keep going. So we're going to actually graph all of these values. Now this graph paper is going to look a little different. So here's our y-axis, and there's our x-axis. We're going to put 360 all the way here. Halfway between 0 and that is going to be 180. And halfway between each of those will be 90 and 270. Halfway between each of those would be our 45 degrees. And if we remember, I only wrote down the 30 degrees. So the middle is 45, a little bit over. That's 30 degrees. So if we try to plot all of our points, before we do that, we need to add a +1 and a -1 on our axes, and we know halfway is the halves. So first coordinate was 0, 0. Second coordinate was 30 degrees and then a half. It's about there. If you want to type in the 45 degrees and then the 60 degrees, we kind of get these decimals. It was 0.7 and 0.87, so kind of about there. With the decimals, you just have to be as accurate as possible. And then at 90 degrees, we got the full 1. And if you keep going with all of these, you will actually find a pattern. So at 150 degrees, which would be about here at that third line, we got our half again. And at 180, we got 0. So if we were to find those other two, we would find that. At 270 degrees, we actually got a -1 and back up to 360. And if we looked at those other numbers with the halves, they'd be about there. Now, 360 degrees is an entire rotation around a circle, and we can go around it again. It just means we would have a very, very large degree of travel. You could travel 500 degrees. You're just spinning in circles at that point. But we would see that it would do the same thing. If we went towards the negative numbers, it would continue like that as well. So we kind of have this wave, if you will. So we're just going to connect all the dots now and would continue on like that, and ta-da. This is the parent function of sine. And like all parent functions, we can move these. Now, let's notice something. Since this is a wave, it just repeats over and over and over again. Why would we in our right minds graph the same thing over and over and over and over and over again? That doesn't seem right. What we do then is we just graph one section of this, which for sine is between 0 and 360 degrees. If we ignore everything outside of this green box, this is the thing that gets repeated over and over. We can copy and paste all along this x-axis, and it's going to be the same thing. So this part is the only part that we are actually going to graph. And this portion is called, it's called a period, which for sine is going to be 360 degrees total. We can also call it one cycle before it repeats again, this is what happens. This is one period for y equals sine of x. Another thing that we can see here is what we call an amplitude. Now, amplitude is how high these waves go. So, if we look at this point here, the distance between the x-axis and that maximum point is 1. And that's the amplitude. We'll use a capital A to denote that. And we can also do that with the other point here. Now that distance is -1, but we don't talk about distance as being negative. So amplitude, we always find that as the absolute value of whatever A is. So either of those could be the amplitude.